Hi, in this video we are going to study forward biasing of PN junction. Now we know that what is PN junction and how it is formed. Now what does forward biasing mean? Biasing, we know that providing voltage or applying potential difference across PN junction. Now what does forward means? Now forward, we know that this is PN junction, this is P-type semiconductor, this is N-type semiconductor. Now if I apply voltage or potential difference across it such that the positive terminal of the battery is attached to the P-type and negative terminal of the battery is connected to N-type semiconductor, then this is called forward biasing of PN junction. Now what happens when PN junction is forward biased? The current flows through it. Now how does current flows through it? Let us see. Now we know that when PN junction was joined, this whole thing happened and then the diffusion of holes and electrons stopped. This was the depletion region formed. But when positive terminal and negative terminal is attached to the PN junction in this manner, what happens is the positive terminal of this battery repels holes of P-type because of positive character, and we know that like charges repel each other. So this positive terminal repels electrons towards the junction. Now we know that this is the fictitious battery which is formed because of these uncompensated atoms. So we know that this is the negative side and this is the positive side. That means they both are in opposite direction. When we apply voltage greater than the voltage of this barrier, what happens is the holes now have the energy to move into the junction, that means to cross the barrier. So when this voltage is greater than the fictitious voltage, these holes move into the junction, and similarly these electrons move into the junction. So what happens is, that means diffusion has started again. That means more holes and electrons will start being compensated. But as these are moving inside the depletion region, what happens? The uncompensated atoms get compensated, because we can see that this is positively charged atom. Electron has entered into the region. That means the charge get compensated. So what happens? This fictitious battery, or we can say the height of the barrier, starts decreasing. So what happens? Now more holes and electrons can move through the junction. So what happens? There is flow of charges. The holes are moving in this direction. The electrons are moving in this direction. So we know that current is the movement of charges. So that means the current has started. This is how the current is flowing in this junction. Now how this current is flowing in the external circuit, let us see. Now we know that electron is moving towards this junction. Now either it can get compensated or it can cross the junction and move into the circuit. That means the external circuit will be moving like this. Electron is moving in this direction, because we know that current moves from positive terminal to the negative terminal. So electron is moving in this direction. So either we can say that these minorities are moving towards the P terminal, or the electrons which can cross the junction and are not compensated move towards the P terminal, or we can say that this P terminal makes the electrons which are present in the covalent bond of the semiconductor of P type. What this terminal does, it makes the bonds to break and electron moves out and moves towards the P terminal. So what happens when the bond breaks here? A hole as well as electron is generated. The electron will move towards the P terminal through the external circuit, and this hole will start moving towards the junction. That means it will start moving towards the negative terminal from N-type semiconductor. So this is how the current is flown in the junction and outer circuit is covered. So that means when PN when junction is forward biased, the fictitious battery's height becomes lower and there is flow of charges. That means the current is formed, and we know that current moves in one direction, so that means it is moving from positive terminal to the negative terminal. And if the potential barrier has lowered, so what does that mean is that the depletion layer has reduced. We know that electrons and holes have entered into the region. That means the depletion region has been minimized. That means the depletion region width has reduced. So when forward biasing of PN junction is done, there is flow of current, and that flow of current is shown, which is interiorly and external circuit, and the potential barrier is lowered and the width of the depletion region is minimized. If we draw the characteristic diagram, that means we are going to take voltage along x-axis and current along y-axis. What happens? If we increase this voltage, first of all, if this voltage applied is lower than this barrier voltage, no current will flow, because this voltage will not be able to push holes across the junction. So when this external voltage is lower than this barrier voltage, when VE is less than VB, that means when external voltage applied is lower than that of the barrier voltage, no current is going to flow. That means we are going to get a graph like this. But as this voltage has increased, that means VE is greater than VB. What happens is, now holes are pushed, that means the current starts flowing. This type of characteristic diagram is shown. Now this voltage, we get maximum current. That means when after this voltage we are going to get high current if the voltage is increased by small amount. So this is the characteristic graph between voltage and current in PN junction. This thing happens, this voltage is called knee voltage because after this voltage the depletion layer is of minimum width. If we increase the external voltage, nothing is going to happen, just current has maximum value and it will flow in the circuit. So this is called the knee voltage. This is the value of the barrier voltage. That means this was the value of the barrier voltage. Earlier, if the voltage applied is lesser than the barrier voltage, no current is going to flow. As soon as we have reached the barrier voltage, there will be starting of moving of holes into the depletion layer. When the voltage applied is more than the barrier voltage, these holes and electrons will cross the junction and current will flow in this way. So this is the characteristic, and this is how current flows in forward biasing of PN junction. In next video, we are going to study the reverse biasing.